Hello everyone, my name is Kelly Chandel Ilumba and I'm going to share with you the summary of my work on statistical machine learning. I work on two tasks, regression and classification. With regression, I work with X and Y as a response variable and X as dependent variable. This is the relationship between X and Y with a plot. We move on the second part with theoretical framework. We see the function space as such as polynomial, the loss function, the theoretical list, the empirical list, and so on. On the third part, we look for estimation and model complexity. We look for OLS and its properties and why it's better to look for it. And we go on the cross validation. With the cross validation, we see by this plot that as the p increase, the degree of polynomial p increase, the cross validation decreases. And when we look for comparison of between a cross validation error and empirical risk, we see that both as the degree of polynomial increases, both decrease, but we see that at a time cross validation tends to increase again. We move on to fourth parts with model comparison and evaluation. With this plot, we can see that the OLS in blue, we can see that with OLS is with higher errors, and the complex model in red memorizes very much errors, and the optimal model seems like the best model as it generalizes errors. In other words, it maximizes the cross validation. Okay. And we are going to see the test errors for those models. We can see that the simplest is the worst model to use, and the optimal and complex model are somehow perform as the same. Okay, with a further analysis using analysis of ANOVA variance, ANOVA, we can see that when we look for the relationship between the two models each other, we can see that there is no relation. Every model differ with other. Okay, we continue with the confidence and the prediction bands. What you have to know here, we have to know that when we say that the lines for the confidence or prediction are pretty wide, it means that there are a lot of uncertainty. And when we look for the simplest model, we can see that they are very wide, and when we look for the optimal model, we can see that they are narrower, which is good. And when we look for confidence and prediction bands for complex model, we can see that there is not stable. Okay, we continue with looking of those model. I'm sorry. Yes, we're looking for another exercise, the second part, with binary classification, where we have two, where is a span or no span message. Okay, we can see here that no spam are more than spam message. Okay, we continue by analyze our rock covers, and by this we can see that the naive is the worst model, and LDA and KDA perform almost the same. And what I'm going to mention here is that LDA and FLDA use in the binary classification, they use the same functions, which the reason why they perform was the way, and I use uh, the LDA. So when we compare those models with the test error distribution with the box plots, I can say that we can see that the LDA, and when I say LDA, I say also FLD. We can see that the LDA is the best model to use. And KDA, even though it can perform well, there are somehow it is unconstant constancy. And the naive bias is the worst. It's obvious that is the worst model. So thank you for your patience.